Good evening, y'all. Another good Sunday night here in the workshop, and another heck of a week for me personally, both in my professional life and here in workshop times. So many good people here tonight. Hi, let's say hi to some people we've already seen in the chat. Thomas, good to see you. Dave, yeah, Thomas says, place your bets are how many premature good nights. I did take somebody's suggestion from last time and move all of the buttons on the stream deck that like do things like shut the stream down, say goodnight early, move them all to like a subfolder of a subfolder, so it takes 2 button presses to get there. So hopefully that means that the end of night will not be a catastrophe, but even more so, hopefully the during the night won't necessarily be a catastrophe. Yeah, so the story with the microphone, it's not purposefully a new setup. I was having... Where's my meters here? I can keep an eye on myself. Having some weird issues with the lav that I usually use. It was like super echoey and strange. I think what has happened, it's one of these smart lavs that like dynamically it's a TRRS connector, right? It's a 4-pin connector, and in theory, it senses what it's connected to and changes its internal configuration between sort of standard and Apple formats so you can use it wherever. And I don't think it's doing that correctly anymore, so it gets really... It's like it doesn't have a ground. It has no ground reference. So... Yeah, I don't know what's happening. So this is the mic that I use for like recording like voiceovers to YouTube videos, like the one YouTube video I do properly every 3 months or so. But it lives nearby, so it's always been the backup, and tonight it's gonna be the thing. So if it sounds weird or too loud or too quiet or the music is too loud, it's totally an experiment in the last 30 minutes. So let me know and we'll tweak it as we go. Yeah, I this is really, I don't know what everyone's talking about. This is sort of the biggest game in town tonight, I think. I was trying to at one point figure out if we could do like a big game little lights something like watch the Super Bowl halftime show together and think of like inspirations for little tiny moving lights to go with it. But I feel like that's just like begging to get a stream or a channel shut down somehow because they're so super duper litigious. So anyway, we'll work on tiny moving lights, and we'll maybe that'll be a fun thing to do next week, because we can look back at the Super Bowl halftime show and be like, ooh, there's a cool fixture. How could we do that, but like at 1/12 scale? Headset mics I could certainly do. I looked at a couple. There's a brand that I like for ham radio purposes. Most of the headset mics that I'm familiar with, at least, are sort of communications oriented. And I know there are like gamer mics now that have decent audio quality. I maybe just am prejudiced against the sound quality of headset mics from like communication focused ones, which really squish everything in. Like they EQ out everything below 600 hertz and above like 3K. It's super punchy and super intelligible, but it sounds kind of like garbage. So I know there's good ones out there, and if anyone has suggestions for something other than this, which just I can't help feeling like there's a thing in my face, I guess is what it feels like, because there is. It also means that if I have to go up to like tummy time into storage behind the camera here, or back to the storage on the back shelf, I either have to shout or just like get some tasteful room ambiance. So we'll just roll with it as we goes. Pokebro says, could you Countryman or DPA use IEMs for monitoring? Yeah, so if I wanted to like, and this is like partly the question is like, how much money do I want to invest in what is ultimately just like a fun hobby for me? But yeah, I could do like an IEM up the back with a little flex cable and a little like actual like, skin tone lav. That might be kind of fun. Yeah, all good ideas for tonight. We'll roll with this. It does mean we can like get in here and have some ASMR lighting times if we really want to. Now, the true Truss segments will be connected together. I feel like we've done that before, but even more so tonight with this right here. So what are we doing tonight? Tonight, it's totally a punt, because, like I say, it's been a busy week for me in the world that's outside of these 4 walls. But I thought we might think about one of the dimensions of the tiny moving lights that needs some improvement, and I really haven't done that much work on yet, which is hanging hardware. Yeah, Chris, that's exactly. It's a Super Bowl joke. We'll see how many Super Bowl puns we can squeeze into tonight. That's one. Somebody keep count for me. So this is currently what the hanging hardware on the Demilight looks like. In fact, let's see. I have a couple of them here. Maybe we'll take this one off and we can look at before. This is an old 0.93, 0.92 version light. assembled, and you can see the two sort of hanging clamps there that are a separate print. They attach down into heat set threaded inserts down in the base piece here. Let me actually grab my Allen keys, and we'll pop those off and take a look. Yeah, they're all currently. I have not. Well, that's not true. I have not done a PETG print or of these in a long time, and I've never tried them in ABS. But yeah, all of this is PLA. In fact, you can see as I'm unscrewing this, some of the things that are just scattered around the workbench here are remnants of. I'm really trying to get rid of my almost completed filament spools, and so I did a batch of Demilight stuff that used up the last of this sort of copper tone filament, and then most of the rest of a white spool, and then got into some of this blue PLA spool. So they kind of end up in this fun multicolor, like nautical-ish tone. Just because I'm trying to make more room on my filament shelves for things that are, actually a useful amount of PLA. So like I say, so this is currently how the hanging hardware would attach. We can zoom in on that there. It's just two M3 heat set inserts, and I think in the assembly night when we built the new model for the first time, we looked at how to install those. And there's instructions on the build website, jeff.glass/demilight/build, for some tips and techniques for getting those in and getting them flush. And this is fine. They're fairly narrow. I want to say these are an M3 by 3 millimeters tall insert, which is not huge, and it does mean if you get any plastic spoil, like if you can actually see on this one, you can see there's a little bit of plastic sort of inside the insert there, and that only having 3 millimeters of thread to work with, that means you're really hosed for space and for threading if you get any little bits of plastic in there. Which is unfortunate. The other reason why I want to move away from this as a strategy for hanging hardware is just because it requires additional external hardware, right? So in this case, every light needs 2 M3 screws and 2 of these M3 heat set inserts. And like I say, that's, when that is the right solution, that is fine. But I don't know about y'all, but when I am looking at a project, say on Thingiverse, I'm like, ooh, that'd be cool to make. This happened to me this week. I was looking at fun, 3D printable mechanical clock designs, that have an armature that ticks back and forth, and a spring sometimes made a plastic spring, and windings, and all very cool. And I found one, I was like, this looks great. I'm going to print one of these with my shiny new printer that I'm still in love with. And what turned me off was, it was like, okay, so here, print these 24 parts. That fine, that's that. Let them run in a few batches overnights, and you're fine. But then you also need, one M4 by 30 millimeter screw, and one M3 by 22 millimeter screw, and one M6 and nuts, and at least I have a collection of some of this hardware. I have a box of M3 and M4 and M2, or I could go to the hardware store and buy the little baggies, right? If you go to Menards or Home Depot or whatever your local hardware store is, and get one screw of the right length for each project, and that's fine. And I have done that before, and that's often for a mechanical project like a clock, having a metal axle or securing point or whatever is critical. But for something like this, I just feel like if there is a way to avoid the end user having to purchase and find and install additional hardware, then all the better, right? And given how simple this, I guess we'll see how simple it is. Given how straightforward this joint is, right? It's ultimately it's a little hook or maybe something else in one of maybe 4 orientations, or maybe 2, depending on how we want to think about it. It seems like there should be a way to make this work with a purely 3D printed fastener. Cookie's done with homework hours early to be here. Hey, Cookie, how are you? Cookie, I think we're gonna have a fun time tonight looking at truss and hanging hardware. I'm really glad to see you here. That'll be fun. Yeah, and as Chris says, if you could find a family-owned hardware store, or I might be wrong about this, but I feel like Ace Hardware is a franchise-only business. I heard somewhere that all Ace Hardwares are franchises, or locally owned hardware stores that are franchised from the Ace company. So maybe an Ace, and the Ace, certainly, at least the ones in Chicago, have a decent selection of metric size parts, as well as imperial size parts. So when we get to assembling some of this D3D truss here later tonight, I'm actually going to be using an imperial equivalent part. But that is also a decent option. Just to clear a little bit of stuff off the workbench before we dive back into problem solving, I did want to share. So I know you're gonna get tired of me talking about the new 3D printer, but it's just so nice. This is one of the steel heat beds from it. So this is the Prusa spring steel sheet. And this is a couple pieces of truss fitments that we'll look at this the full page and the full slicing of these later. But I just wanted to show you just how good. Here, maybe we'll do a little ASMR thing. We'll get the mic real close to it, and we'll pop it off. I don't know if you heard that at all, but it makes a very satisfying noise when you pop it off the spring steel sheet there. Yeah, Chris, just the smooth sheet. I didn't order the textured one, but for PLA, the smooth works really nicely for me at least. Put that up out of the way here. Depending on how far we get tonight, and I don't intend it to be a super duper late night, we may end up 3D printing some of the things that we design and think about this evening before the end of the evening, because the printer's just here and it's pretty quiet. I don't know if you'll be able to hear it, but at this point, I think that'd be kind of a fun thing, just to be like, oh, here's a cool idea if we could 3D print it, and then we print it and see if it works. But we'll see if that's over ambitious for this evening. Yeah, so that's what I think we want to think about tonight. And sort of along with that, I want to think a little bit about truss and support structures. So these are some pieces of a truss structure that is not my invention at all. These were sent to me by our friend and cohort, who goes by many aliases. But you can find these prints, and I like them a lot. Here, let's take you over to here, over on Prusa printers, and this is linked in the description. If you want to just go straight to it, the complete truss and accessory pack. That has a variety of different sizes of truss and corner blocks and floor stands and hanging brackets and screw jacks, and they all just fit together. I think they're designed, let's see, for an M4 screw. I found that in imperial sizes, a number 6 screw is pretty close. That will work for our purposes if metric is not something you have ready access to. But yeah, so as we're looking at something like this, and I have messed around with much simpler trusses before. This is a little piece of 1-inch triangle truss that is. I mean, there's no diagonals here at all. Like, there's no cross supports. It prints fairly quickly, and it has these sort of slide-on hanging brackets, right? So these are just a pressure fit that would slide on, and they connect a piece of truss to the next adjacent truss, and they have one point that you could sort of suspend this from. Yeah, so let's see. So I've got a bunch of M6 hardware just here. And at least to within the tolerances that I'm working in, it works pretty well. So it's a little bit loose in there. So I don't know how good this will be. Maybe take the not black one, Jeff. That'll show up on camera. We'll thread that in there. Yeah, so you can see it's a little bit loose, but once you thread it down with a wing nut and or a lock washer, that tends to work out pretty well. And partly why I did it is that, like, at least where I am these days, going to the big box store, I can get, a pack of 10 of these number 6 1-inch screws for, I think this was 80 cents, whereas the number 4 hardware, if I want to get it locally, is like 40 cents for one. For online, it's pretty much a wash, but at least buying in bulk locally, like, that would seem to be a decent option. So one thing I want to think about with all these truss systems is how to mount the lights to the truss. And partly why I originally made a 1-inch triangle truss is that I was like, well, I'll do a 1-inch, I'll do a 25.4 millimeter spacing for my hardware, and then I can sort of hang either off of one of the side members like so, or I could rotate the clamps 90 degrees and hang across the truss. I could hang across the truss if my electrician hands could figure that out. Yeah, and it could hang like that. And that's a totally arbitrary measurement, right? These posts, these placements in the base of the unit could be at any spacing. I just sort of chose 1 inch because it seems to fit with my Cromulent plans. But so playing around with Cookie's truss here is thinking about ways to modify our thinking about this hanging hardware so that it could accommodate different sizes of truss and different placements. So right now, right on this truss, it could hang on one of the side members, right? Just rotate that a little bit. We could hang off of. Actually, might not be able to hang off of the side members just because my clamps are my quote unquote clamps are too far apart. Huh? I think we can get it in here. Hang on, there we go. So 1 and 2, yeah. So just barely fits in there, so we could hang it off a side member like that, or we could hang it from a center post like this, that's a pretty good solution. The only hang up there is that at least in the sizes of truss that I have the capacity to print, that means I can only hang one light per one of these sticks. Now I say it out loud, it's actually not maybe necessarily a hang up, because let's look at the size and the clearance of the light itself in comparison to the stick of truss. We might actually need that much clearance. This, I think, is a 100mm stick. Chris says, where is the bolt to lock it to the truss? I don't know what you're talking about, Chris. Should be fine. These, as I think I've said before, are not rated for any kind of overhead use. That's actually not... If we look at like the clearance that the light needs in comparison to this stick of truss, that's actually quite nice. You know, I don't know that I'd want to like squeeze them any closer than that together. Oh, and Cookie says 200mm prints diagonally on the Mini. Oh, that's good to know. Oh, very good. Yeah, because the Mini has a 180 by 180mm square bed, but 200 prints diagonally. That's awesome. Chris and Thomas both point out that a safety cable is not a bad idea. You're not wrong. You're not wrong. So we could even build into the next iteration of this print. Maybe there's a little point here that you could just either clip or put a piece of baling wire or mousing wire maybe that goes to your truss archer. I mean, it should go without saying, like, if you're ever worried that this might fall on somebody, don't. This is a hobby project by me at this point. Fishing line with jewelry would work. A bunch of like soldered paper clips would work. That's a good for future improvement feature. So one thing I had been thinking about before I started looking at the size of this 100mm stick of truss in detail is how, would we want to have some kind of additional bracket that could span the two members of this truss or any truss and provide a mounting point for something like this hook. But since this, and so I guess there's really three things we might change. One is like rethinking how the hook attaches to the body. The second is, to your point about like where is the bolt to attach the hook to anything, rethinking what this attachment mechanism is. And third, is there either accessories to this ecosystem or to other systems in general? Maybe it's something like, just to mock it up, here's a little suspension bar, right? If it was something like this hung from the inside of the truss and then the light hung down, from that or something. And then this piece, which has a purpose in this ecosystem to, presumably to hold the truss up or mount things to it. This is a relatively straightforward piece. In fact, straightforward enough that it's something like Thingiverse Customizer, which interacts with SCAD models, which are software designed CAD models in a very real way, right? You could say, okay, the two members of my truss are, X millimeters on center and they have diameter of Y millimeters, and it would generate this piece for you with whatever attachment points your lights need. That's not a terribly complicated thing. So that's sort of the three pieces of this puzzle, and as you can sort of tell as I'm bouncing around between all of them, they all kind of interact with each other, and one might inform the other. And so it's good to see lots of friendly faces here tonight, because as you have been, if you have thoughts or ways that I could do these things better, I'm all ears, because this is a puzzle things out kind of night, not so much a share what I have done this week kind of night, because it has frankly not been all that much on this project. More like a spend a working night here figuring out how to solve this thing. We may do a little CAD drafting, we'll take it into Fusion, and puzzle out some things. And I think where I want to start is with this attachment between the body of the light and whatever this hook or, clamp or whatever it ends up being, whatever this turns into, just to try and eliminate these two M3 screw positions. So this may take a little bit of noodling in CAD and in person to figure out if any of this is plausible. But I think I want to find a way to basically attach, I guess here's the specs, right? I want to be able to attach two separate of these, whatever these clamps end up being, ideally in any orientation, or in a locking to 90 degrees orientation, right? So forward, back, left, right. Or, all the primary compass directions, because those are really the ones we're mostly going to be interested in hanging this thing in. And it should be relatively easy to print. So one thing that's nice about these designs is it's essentially, you can tell here, it's a flat profile, right? There's a little bit of chamfering on the base there, but essentially they just print flat on the bed like that, and that's a really good feature. Mechanical engineering, Gaddy goes over my head, says, broke both, prefer software. Fun to watch somebody figure it out. Well, you're in luck, because I think there's going to be a lot of trying to figure it out tonight. I actually pulled, maybe I didn't bring it in here because it ended up not being that useful a resource, but one of my favorite books for noodling on mechanical problems is a book called 1800 here. It's even in my Google Save searches. 1800 Mechanical Movements, Devices, and Appliances. This is a super cool book. Let's see if we can find... can we Google Books it? Can we get inside? Here we go. This is a super cool compendium of just like view ebook. Can I just look inside of it? Here, selected pages. So the pages are just full of mostly antiquated designs for things. So here's a random page. The water tube boiler, the Boyer's tube boiler, the Hazelton boilers, right? So clearly we're in the page of boilers. Let's go to here where we are, recording pressure gauge, and it gives you like this one paragraph description of this very intricate design for various like geared and levered mechanisms. And I just like to flip through it sometimes and be like, ooh, that's an interesting way to link things together. It's got a whole section on linkages and mechanics that's quite fun. So anyway, it doesn't have a whole lot on like interlinking two parts just rigidly. It's mostly meant to be like translation of motion from rotational to linear, or one axis to another, or steam to motion, or water, or gearing, or things like that. It's not a lot of like rigid affixments, so I didn't decide to use it. But anyway, I wanted to shout it out because it's pretty cool. Chris says, is it better than the 507? I don't know that it's better. It's dense. So the 507 Mechanical Movements, Mechanisms, and Devices. Let's see if we can get inside that one. That one has a nice, like, sort of web version. So one thing I do like, let's see if these ones have the same. Yeah, so it's very, very similar in feel to this. This is at 507movements.com. You get things like it starts to spark your imagination. Like, I'm not even sure what you would use this for, but you're translating presumably two non-concentric axes of motion while doing a sort of gear reduction between them. It's like, ooh, that's kind of fun. So anyway, fun things if you're like, oh, I need some brain juice. I need to noodle around a little bit. So yeah, it's not really necessarily like informational as a reference. I find it just exciting to be like, oh yeah, okay, linkages with gears on them and an arm and a piston and yeah, it's just a funky thing to do. I'm actually realizing, hang on 1 second here. You don't get tummy cramps tonight. I'm sorry. Adjust the thing. There we go. We're back. Hello. Thank you. Sorry, I had to turn a thing off. There was a weird light in the background. I was kept being like, am I crazy? No, it's a weird light in the background. Let's get into CAD and start figuring some stuff out. Like I said, I don't know that CAD is going to be the best place to work these things out, but it's at least a place to start. And I'm not going to take us into the full Demilight model to start with either, just because it is so, the timeline is so long and so messy that I think it's going to slow the computer down enough, especially trying to do it on stream, that we'll just start from sort of a scratch plate and see where that takes us. Did we do? We did a night talking about Fusion back in December, I feel like. Here, let's save this. We'll save that in Moving Lights. We'll call this Hook Experiments. Here, and you don't need to see the table for this for now. So here's an idea that's been kicking around in my head that I haven't thought it through enough to know that it is good. It's just kind of invaded my brain enough that I feel like I need to sort of get it onto paper, as it were, at least to validate like why it doesn't work. And I think why the reason it doesn't really work is clearance. But let me show you what I'm thinking. And I'm be a little bit sloppy about the drafting here. just for the sake of slapping this together. This would be the equivalent, I think, of a sketch, not like a fusion sketch, but a sketch on paper sketch. So we will, just to give ourselves a place to start with, we will give ourselves a plate. We might as well make it the dimensions of the Demilight base, which are 35 to 30 and by 36 millimeters. I don't remember what the depth is. Let's say it's 2 millimeters. Like I say, we'll go back and make this precise to the actual model at some point. I just need to let's just get some experiments out, and because if we're gonna ultimately learn that they don't work, then why spend a bunch of time on them? So we'll make a new component for our. We'll call this hook 1. That's a name that's not gonna come back and bite me at all. So here's what I'm imagining. I'm imagining a device shaped like let's see, how am I going to best demonstrate this? How about a piece of solder? Just need a flexible bit of something to work with here. So why not a piece of lead? So I'm imagining a hook shape something like this internally, and then this, not to scale, of course, represents the outer part of the hook. This is sort of more rectilinear like that. So there would be a slot in the base of the light itself through which this arm can go, and it goes down pretty far. This hook part clears the bottom. Then this hook would rotate over to the desired angle, and then it would hook sort of back up into a hole or post or something like that. That would allow it to sort of stay in a given one of 4 orientations. Obviously, this would only work for light hanging straight down. Is one of the flaws in this plan. So that's the option that's been stuck in my head, is this like slot in and rotate around and then like sort of lock back in by pulling outward on the unit. So let's draft that one up, and before we get too far down the rabbit hole into other ideas, because certainly that is not the only one that's kicking around. So drafting that out, let us see here. Let us draft out the hook in its how do we want to do this? We probably want to do it in its like the hook is in place, the light is hung position, as it were. So let's start with a sketch on our bottom face here. This may not be to scale ultimately, but let's say that we have a 6 millimeter by 2.4. How wide are these that we have on the table here? Grab my calipers. So these existing hooks are 10 millimeters across. That feels about right. Could maybe be a little bit smaller. I think for this purpose, it's actually going to need to be a little bit smaller. So why don't we make these 8 millimeters across by 10 millimeters? Gosh, that's going to be huge. I guess the arm doesn't have to be the same width as the hook itself. That would be quite handy. So let's say that these are in fact 4 millimeters by 8 millimeters. And if this is not making sense, I apologize. I think it will once I can get it into motion. Oops, where's my sketch? There we go. So we'll draw a line up from here. And then what I want is a circle through 3 points. And they are this, and let's say that. And there we go. Okay, so this is going to be the first body of our hook arm, as it were. Let's say that's 2 millimeters. All right, sort of hanging down inside of the body of the light, as it were. And you know what I do? I think what I want to do sort of right off the bat, I mean, one is I could move this to some more cromulent position. Ooh, Francesco's sent me a little loading symbol. Are my how is the stream health tonight? I know we had some issues last week with things being a little buffery and stuttery. How are we doing tonight? I have an indicator on my end, but I'm not very good at remembering to glance over to it. What I'm going to do is rotate this by 45 degrees because I think that will enable me. Let's see, selection axis. I want to rotate around, not that, but how about this? No. I think having a hole that is offset by 45 degrees is going to allow me to maintain the ability to lock this arm at any of the 4 sort of compass point positions. Let's see. So we'll rotate it like 45 degrees that way. And we will move this somewhere. Let's see. Should probably put this on something like a center line, but just as a sketch of a thing, I think that'll be fine. Okay, so that's fine. That extrudes. Okay. So then this thing in my imagination, which is the only place it exists right now, is going to have a little tooth that sits back up into the body of the light. So we will draw a little line there, and let's say that this is 3 millimeters, and we will extrude it, say 1.2 millimeters up. Okay, so there's that. And I'm not, so ultimately, so right now these two bodies are intersecting, right? This arm and this plate, which is representing the bottom of the well, I guess I'm confusing bottom and top quite a bit here, but calling this the bottom surface of the light makes sense to me. So right now these two bodies are intersecting, but I'm actually not going to fix that yet. We'll come back and fix that a little bit later. We'll just cut away a lot of this bottom at the same time. So now let's make the upper part of the hook. And to do that, I am going to take my circle here. I'm going to make it an actual circle on this layer, and I'm going to extrude that as a cylinder just a little bit, how about 0.4 millimeters above the bottom surface of my Demilight. We'll say to object. I feel like, and I wouldn't blame anyone, I feel like all these words that I'm saying only like 70% make sense when I say them, so so forgive me. I'm feeling the like, well, what I hope what Jeff's talking about makes sense at some point. I hope so too, dear viewer. So now we would create the actual part of the hook itself. So what we will do is, oh, you know what might be classy? Let's not make a sketch right on this layer. We'll make an offset plane, say 5 millimeters above it, and start the rectangular portion of the hook there, and then we'll loft between those two shapes. And that'll make a nice smooth transition. And won't that be classy? So here, what we will do is we'll make a sketch line just there, and we will start making the actual sort of arc of our hook. So we'll say that this is, we said our hook was 10 millimeters wide, and that felt about right. So this will be 5 millimeters, and thickness-wise, let's say it's going to be 3 millimeters total. And then we'll just take these lines and mirror them. This is one of my favorite techniques when I'm drafting a symmetrical thing, is just to make 1/4 of it, and then mirror it across the relevant dimensions. So we get, oops, not that. I want to use that as my mirror line. So now we have a rectangle that is exactly centered on this circle. Now let's steal some more dimensions from this is all assuming that we're, mimicking this existing hook exactly, which, as we talked about earlier, is not necessarily the goal, but as a place to start to work out the attachment mechanism, I think is a decent place to start. So that is about 16 millimeters there. That's been feeling about right. So what I will do is extrude this 11 millimeters, because we already have our 5 millimeters down here. And then, let's see if I get this right. I want to I want to loft between this profile and that profile. And I should get a nice smoothly varying shape between those two. That's going to become our interface point. And now we'll make the rest of our hook here. So we'll make a sketch on this side, and we will create a couple of circles in line with our sort of vertical arm of our hook here. Let me steal a couple of quick dimensions for them. I think I made the inner dimension here arbitrarily about 1/4 of an inch. Maybe a little bit bigger. 0.78 millimeters there. And I guess what was total thickness on this? About 3 millimeters. Okay, that's pretty good. 0.78 millimeters. So, coming back over here, we will say that if we put a point across here, put a point and a point, and we will say that this is 0.78 millimeters. Oops, not 0.78, 7.8 millimeters is what I should have said. It's a very small bit of truss there. And then it's just we won't cut it off perfectly horizontal. We'll make this extra line here so we have a little bit of sort of overhang on our hook. And maybe we want to give that a dimension just so it's well defined. Let's say that's 10 degrees. We may want to come back and finish that later. We'll make an offset plane on the other side of our hook, and then we'll extrude this profile that we made straight across to there. Okay, so there's the basis of what I'm proposing for our new hook. Now let's deal with how it would actually interface with the base of the thing, right? Because right now these two things are sitting inside of each other, so to speak, because there's no interface between them. So first things first, let's just do a basic cut. Let's do so we'll use the combine operation on the body. We'll use our hook as our tool body, and we'll do a cut, and we'll keep the tool so we don't delete our hook after this operation. Let's see here. Did that take? If I turn this off, yes. So now we have a hole and a notch, so to speak, in our base here. And now I wonder if I could. So there's a couple of ways we could turn this into 4 notches, but I think I'm going to take the sort of lazy way out. I'm going to create just like before. I spend a lot of my time, and there are probably faster workflows than this. I'll spend a lot of my time, just making 2 sets of axes and then mirroring across one axis and then mirroring across the other axis, and to get myself 4 radially symmetrical points. I guess I could do a rotational pattern. That would be a slightly faster way to do it in Fusion. But this is a workflow that's very familiar to me by now, right? So I select those 2 notches, mirror them across. These 2 notches, mirror them. Mirror them across, and now I want to make these other 3 notches the same depth as this first notch. Let's see there. Is that the right place? No. That is on the surface here. We'll turn our sketches off for a second. So I want to make a notch that's as deep as this hole here, although it's not letting me get into that hole. Maybe the sketches are... There we go. I want to make a plane that is coplanar with the inner point of this notch, so to speak. And then I'm going to cut the other 3 notches to that plane. And hopefully... Ooh. Well, that's not right. We'll try it again. Take those 3 profiles. We'll do an extrude cut the distance of that plane. Yeah, okay. So now I have my 4 sort of registration points there. Why cut to the plane, not just to the face? At least in previous versions of Fusion, maybe this is no longer true. Let's find out. Deselect that object. Can I just cut to... Oh, you totally can. So in previous versions of Fusion, there were times where it wouldn't recognize how deep you were meaning to cut, because it's a little bit ambiguous, right? If this was, for example, a non-planar surface, you could still specify, cutting to that position. But if the surface itself doesn't extend as far over as you would want to go. You get this error like could not create tool bodies. It'd be like I don't know what your position is meant to indicate here. Is it coplanar with this point or that point or this curve, or am I supposed to extrapolate the curve? I guess at least in the current version of Fusion, you can just use a plane as the cut surface. I guess it's now an out-of-date habit to create a zero offset plane there, but that's good to know. Thanks, Chris. So the last step here, turn our hook back on, is we'll need a way to get this hook down into this base. So what I am going to do is create one more sketch on the base of my plate here, and I am going to project the profile of my my arm here, and then I'm going to take those various parts, and not this corner and not that corner, and I'm going to make a copy of them, but rotated. Let's see. Ooh, is it not going to let me move copy a projected point? Ah, that's a bummer. We may have to go over them, which is a little bit of a silly thing to have to do. We will do a 3-point rectangle tool, which is a good way. 3-point rectangle tool is a great way to, get rectangles on non-perpendicular axes. And we'll just take our circle and the relevant lines of our rectangle and rotate them by, say, 45 degrees. Will you let me do that? You let me do that? Not so much, huh? Maybe it's because they have constraints. They're constrained to be immediately on top of the shapes that they're based on. That would make some sense. Let's see here. Yeah, I think that is what's happening. So, maybe this is not quite the best way to do this. We'll project that shape in. Copy and rotate. So, let's see here. Copy. Take that point out. Oops, take that point out. Copy. What I don't think it's letting me do, Chris, and I might just... Oops. Is... Oh, it is letting me move them now. That's a good sign. Let's see here. Ah, yes, because I just copy-pasted it, didn't bring the constraints along with it. That's quite clever. Let's see, is that just the circle again? I want sketch objects. I want this circle, I want that line, and that line, and I want them to rotate. There we go. Yes, excellent. Thanks, Chris. Saving my bacon tonight. Now we'll finish that, and we will extrude. I think I need one more line to this sketch. Why is this not a region? Maybe we will draw from the circle to that point. Oh, maybe we are seeing some other body. Yes, the hook is getting in our way, so get rid of that hook. And now we should be able to, yes, extrude, cut, to object, all the way to the top, cut, and there we go. Okay, so... So now, all of you who've been waiting patiently for me to figure out what the heck is going on, and actually, there's one more thing I have to do, which is adjust some of the dimensions on this hook, specifically this extrude, or really this construction plane needs to be as tall as that lower notch is, plus a little bit. Let's do 1.6. Okay, we got there through a bunch of rambling. So here's the gist of this idea. You take this hook part, you rotate it 45 degrees to where it is now. It goes down through this keyhole slot underneath. It rotates around to one of these 4 positions, and then it pulls back up slightly into those one of those 4 slots. And there it is sort of not anchored, but its orientation is captive in that position, right? So it would lock itself to one of those 45-degree positions. Now, obviously, there's no clearances built into this yet, which would be the sort of the next thing to solve. but I think this has some merit. Let us do a thing that I often do in these situations just to like see if it's worth trying. Is I'm just going to open Prusa Slicer and see how long it would take to print something like this. To see if we can like run off a test copy tonight while we work on other things and then come back to it. Maybe working on other ideas for the same project. And just because I'm feeling very lazy, rather than going back and editing the original size, I am just going to sort of manually cut away the extraneous parts here. Boop. So we are left just with the active bit. So let's export these as STLs, and as Chris, is rightfully saying, I have to come back to do clearances before it prints. But this is something I do. I'll just be like, hey, if I wanted to throw one of the, it's a 12-minute print. Well, I'll just get it going while I work on more things. Save this in my moving lights folder. You don't set it directly to Prusa prints? No, I like to have a separate copy of all of the STLs that I print, as well as all of the exported G code I save for every print that I do. So this is plate 1. And I will confess, I rarely need that, but there are times when knowing that I have the exact STL or the exact, especially the G code that I printed on a specific date and time, can be really helpful when I'm going back and trying to integrate with it. So no, so I don't send it just directly over to the printer in that way. So let's bring our hook and plate in here. And now I guess another problem is thinking about print orientation for these. Let's flip this guy on its side. That's not awful. With supports, that would print just fine. And this guy is a really easy print, right? We'll put it with the notched side up. And let's print this in 0.2 millimeter speed mode. This Prusa Slicer thinks that this is a 20-minute print. Not bad at all. Well, great. Well, we can certainly make that happen tonight. So let's go back in, and Chris had 35 minutes. Chris, you were so close. We'll go back in and we'll clean up some of these clearances, and then we'll get this thing printing out. So let's see here. So we did let's go back into our sketch where we made our notches here, and rather than just having them be exactly the size of our of the tab on our hook, we'll make them just a little bit larger. I'm gonna guess we need 0.4 millimeters of clearance overall, so I'm gonna add 0.2 millimeters on all sides. It's a little bit of a guess. In fact, maybe for testing purposes, let's go a little bit overboard. Let's give ourselves 0.6 millimeters to play with, so that even, it'll probably mean, I guess we'd rather have a little bit of shakiness in this arrangement for the sake of validating this, this slot idea, rather than not be able to get the thing in and then we really can't validate anything. Yeah, I think, having it go in and being a little bit sloppy is probably preferred in this case. To I can't get it in the hole, and now I don't know if this idea works. And we'll mirror that across. All right, so we'll finish that, and we will make sure that we are. So this is one thing that we talked about in the night we talked about doing fusion work is rather than so going from the end of my timeline here and making changes, I'm going back to the earlier steps in my timeline and making the modifications sort of that I should have made at that point. Similarly here for this keyhole, I am going to apply some tolerance to both the hole itself and to my my slot there, and then I'll make sure that we cut both of those out. Now, where is my sketch that I actually want to cut? That's not the right one. It's this. Yes. So we'll include this additional area here, so we have a nice bit of clearance. It says I missed the bottom left one. Thank you, Chris. Let me go back and get that. The bottom left notch, I'm thinking you mean. Let's, that would be this. Yes. Excellent. Dink. Yeah. Thank you. All right, so that's some clearance on the hole and the keyhole there, and I think that's the only places we need clearance, because that's the only places they interact. So another neat feature, and I guess I've never played with how this interacts with the send straight to 3D printing utility method in Fusion Works. So I'm just going to re-export my plate object here as an STL, and it says it already exists. Do you want to replace it? Yes, I do, please. And I'll do the same for my hook, and we'll save that as the same name. And then in Prusa Slicer, I can come in and say reload from disk, and it will upload. It will modify the opens the newer version in Slicer. If you send it again, I wonder. Yeah. All right. Well, that's good to know, Chris. That's how it should work for sure. I guess we'll want to make sure that we've enabled supports. Generate supports, please. All right, now let's slice. Slice now. 22 minutes now with supports on. That seems reasonable. Well, let's give it a shot. So I'm going to export this G-code. Like I say, I save all of the G-code for all of my prints. So I can sometimes go back and be like, what settings did I print this on? What temperatures did I print this on? I don't have to do that often, but when I need to, it's very, very handy. So we're gonna find out. I sort of suspect that y'all won't be able to hear me super well when I'm monkeying around with the printer here, but hang on for a moment. Enjoy some cool jams. Questions if you got them. Oh, I never said tonight. My beverage of choice is a Sierra Nevada Wild Little Thing slightly sour ale. Now, I am not a sour ale guy, but this is only slightly sour, and I find that quite good. The other advantage of the in-my-face microphone is I don't have to mute myself to drink. I can just slide away from it. Very convenient. I guess I could smack my lips on the mic too. That would be nice. We'll see. We'll see if I have enough headset length. Headphone cord length to do everything I need to do up here. I think I will. Let's see here. Plug in the ye olde flash drive. When you stand up, we can't hear you. Yeah, that makes sense, Chris. So now we'll take our files here. We'll open up our moving light. We'll take our hook design. We'll put it on our flash drive. B. Pauline says 20% infill just for this test print. Yes, although if you look at from a model this small, I usually don't worry too much about infill amount, because if you look at how much infill is actually in there, it's hardly any. It's not going to make a huge difference to the actual mechanical strength of the print compared to the sidewalls. For something bigger, I might add a little more infill, although, to be honest, I find that increasing the number of perimeters and walls makes a bigger difference to strength than infill percentage. Infill percentage tends to make a difference, I think, in overall crushability, but not sort of for actually strong parts. But that's just my experience. All right, now I understand when I stand up here, you're not going to be able to hear anything that I say, but you just enjoy the view. Starting the printer. Give me one moment. Just yell, says Chris. I don't know. I feel like if I started yelling about 3D printing filaments, I I can hear that my wife is in the kitchen at the moment, and I feel like she might have some concerns about things. Given that when I'm yelling, it's usually because I've either burned or cut myself in here. So that's exciting. So that's one draft. That's going to the printer now, that's great. That's good progress for, I don't know, 20 minutes of drafting tops. That's, like I say, that's the idea that's been kicking around my head for a while, and I had to get it out so we can play with it and see why it's not good. Yeah, so thinking about... So I guess the other piece of inspiration for connectors this week, for like how to connect two bodies together, is... where is it? It's just here. Hang on. No camera on the printer. Yeah, I certainly could, Chris. Actually, if you looked really closely behind me, you could maybe tell. So that screen just there is one of the additions to the workshop this week. That is showing the Prusa Connect interface. That's the little web interface that's being served by the printer itself. In fact, we're going to have to use the computer to do it, but if we had a second computer or, that Raspberry Pi setup from the Raspberry Pi Nights, we could just keep track of the print time on that. .0.119, I think it is. Yeah, so if we send it to its IP address, we just get that same little local interface here, and it should give us estimated print time. So we can actually just check back in with this every once in a while if we feel like it. And like I say, that is what I have on the TV behind me there. Sidebar about this TV. This was a free TV. Got it from the neighborhood. Like, don't throw anything away. We'll give it to a good home organization, which is great. Have it hooked up to a little Raspberry Pi. It's fine. It's a 1366 by 768 native resolution TV. It's fairly old. It's cool. It has HDMI, VGA, composite, component, and a tuner input, like an RF input for an antenna. So there's a lot of fun playing around with it there. 1366 by 768 is not super kind to Raspberry Pis. This is not the first time I've run into that. And currently, though the Pi is happy to put out data over its HDMI port, the TV, no matter what setting I'm putting it, is interpreting it as a 640 by 480 data stream, and then upscaling it. So it's very low resolution. I'm sure you can't tell on over stream and the internet and everything, but that is very, very strange. Oh yeah, Chris, Prusa Connect. Yeah, if your Prusa is on your local network, currently only wired because their Wi-Fi upgrade is still coming, you just point your web browser at the IP address of your printer, which you can see in the settings. You can make it it's by default as DHCP. If you want to configure it otherwise, you basically you change a text file that's on your flash drive. And there's instructions in the manual or online about this. Googling would be smarter than I am. And then it sets your static IP address if you want it to, and then you can just pull it up anytime. Is that a mini-only thing? I don't know, to be perfectly honest. I've only ever looked at it on the mini. Yeah, I don't know. Where were we? Oh, yes, thinking about other ways to connect things together. This was my Zen project of the week. Cookie says that Prusa Connect is just a mini thing. So this was, you may have guessed, you may have gathered that I'm a nerd. I hope that's not a surprise to anybody. So the brief story behind this is in one of the Dungeons and Dragons groups that I play in, my character recently obtained a magical mechanical globe, which solved a lot of problems for him, and that was great. And so I was like, well, that's fun. I wish I had a toy, prop mechanical globe to play with to heighten the immersion, just because I think that'd be fun. Could I 3D print such a thing? And I did. This is not my own design. I should have linked it in the description. Maybe, if you're watching this after the fact, I probably have linked it in the description. Those of you who are watching live, you get the mystery of the unknown. This is a geared cube mechanism that some cool person on the internet has designed, and it interlocks in all these neat ways, and it has all these interesting sort of gear decorations on it, and so I printed it in 2 colors, this sort of copper brown and Prusa Galaxy Silver, and then went through and painted it with some more like rust colors and things. So this is a fun project for this week. But why I bring it up here is not just to show it off, although I think it's an amazing design. It printed flawlessly, and I'm for the first time really painting a 3D print in this kind of way. Had a great time. It's not great. It's not like perfect, but it's a lot of fun. Why I bring this up is because of how these pieces attach to the sort of central core here, and that is with these flexible pins, so to speak. So let me pull one out. So this is what these pieces are connected with. There's 8 of these, and they go into these inner... There's a sort of a dimple on the center side, and there's a matching dimple on the outside. Now, some of these pieces have to rotate relative to the core, and some of them do not. So this one, for example, has a round hole, so this peg can rotate freely within it, and then it's in a fixed position on the sort of core piece itself, so they don't interact with each other. And that's interesting to me. Like, it's not a super positive connection, so there's some ways in which, like, relying on this kind of snap fit mechanism to, suspend even a tiny, 40-gram light overhead is a little bit worrisome. Although, to your point from earlier, Chris Thomas, if we were to add something like a safety cable, maybe that would be a slightly better idea. But this has got interesting possibilities, partly just for the simplicity of the mechanism. Let's see if you can see this on here. Maybe if I take one of the silver pieces out, it'll be a little bit easier to see. There's basically it's just so one of the cool things about the silver pieces is they're actually 2 separate pieces. So there's an inner bit that spins within the outer bit. Really cool design. I'll see if I can figure out what it was called and link to it. Here, as long as we're here. Let's just leave, we can leave the Prusa Connect up on the side there. Keep a half an eye on it. We're already at 18%. Things will be done at 8:19 Chicago time, and its estimates are usually pretty good. Is that still in there? Yeah. So what I was trying to show, and actually I don't know that I will super be able to, is there is basically it's just a hole with a little lip around the inside here that our pins sort of snap into on both sides. Right, so as this sort of presses in, you can kind of tell that these pins have a slightly sort of arrowhead shape. It's not just a straight pin. They sort of flex out, and then there's this notch in the center. So you press the pin in, it flexes a little bit, and then when it reaches that notch snaps back out and catches that lip on both of the pieces, and that's what sort of retains them in place. And I think that's an interesting idea. One possible flaw, of course, is that is not going to be super tolerant of... the tolerances are going to potentially change significantly on various people's printers, right? Like, what the tolerance and the snap fit of that might work well on my printer, but it might not work so well on yours. Also doesn't help if I put these cubes back in the wrong orientation. But that's kind of interesting. It might be fun to kind of replicate that and see how it performs. I also, if anyone out there has ideas for how to get these hooks to attach to the Demilight, I am all ears. Like I said, this is more of a playing around evening than a Jeff knows what he's doing kind of an evening. So what I think we're gonna do to start with, let's see. You know what? Let's start by, we'll create a new Fusion document, and I'm just going to pull in as a mesh, I think, these 3D printed parts for this whatchamathingy. Steampunk Cube Gears was the name of the file. So let's pull in, let's say, the centerpiece, and here we'll have to pull them in one at a time, but we can pull some dimensions off of them in situ here. Well, let's save this real quick. We'll save this in pin experiments, and we will insert our center here. Yeah, it's fine. And they're coming in as meshes, but that'll be fine if we're just taking measurements off them, just to kind of examine how this person did this design, and how much lip is there, for example, on one of these holes. versus how much spacing is in here. Because to be perfectly honest, if I was going to start something like this, the first thing I would do is just rip off this design wholesale and copy these dimensions over, because I think they have some possibility. Now, here's an interesting thought. Could we sort of combine these two ideas, right? So this peg design is meant so, the pieces can rotate, 360 degrees within a circular shell, or in some cases they're locked into exactly one orientation, right? As we saw, if the hole is the same shape as the pin, then the pin itself is not going to rotate. And that's what, in these corner pieces, that's actually what keeps the center sections there static with relation to the core, while this top piece rotates around them using that pin as an axis, right? But that center piece down there, that little ball, is not actually moving. And it's the same on all four of these, right? This little mechanism in here isn't actually moving relative to the center. This is just rotating around it. Could we potentially do some combination of these two ideas? So here's what I'm imagining, right, is a version of this. I guess, let's see. Try to do a better job of explaining this one than I did the last one. We'll keep getting better. I don't know if it'll be good, but we'll keep getting better, right? So imagine that this surface here is the bottom plate of the Demilight itself. And this pin, let's say sort of the one half of this pin is integral to the hook itself. So we have something like a hook with a built-in pin, something like that. And so if the pin were to just go into, we'll take this off. We can do better visuals with better props. Let me take this hook off of our Demilight friend here. Cookie likes the idea. It's got some legs, right? It's got some possibilities, right? So if we imagine this hook and pin are sort of one piece, right? They're sort of like that. Then we stick this pin in, and the hook is now securely attached, but because our hole is circular, this can spin, to any of 360 degree rotations, which actually might not necessarily be a bad thing if it just has full range of motion. Where I was going was one of two places. One is it could be that this is a circular hole in our bottom plate here, but there is some kind of small registration pins or hooks that when you press the hook all the way down into the surface, the little pins in this, and by pins I mean printed parts, the pins engage a small hole in the surface here, right, and lock you into one of a specific number of orientations. I guess the other thing we could do is just, rather than having this be a circular hole, it could be, if we go back to the computer, it could be, let's say, two holes this shape at 90-degree angles, right? So you could put your pin in how do I film this? In this orientation, right? Or 90 degrees to it. If we imagine this is sort of a cross-shaped hole, go in that orientation, but it couldn't slide between the two without pulling the pin out and putting it back in. That's kind of interesting. That sort of minimizes the clunkiness of the hook itself, which I rather like. Yeah, that's kind of interesting. Let's see if we can get this idea tested out. One thing I think I'm going to do is I really am just going to steal this exact pin design, and I will make sure that by the time this dawn tomorrow, I will have the link to this actual project in the video description, just because I'm gonna rip it off, and it's really quite a cool solution to this problem. So to do that, let's get back into CAD here. I guess before I do, just a real quick, I could use what those who have been here before know. But this all started as like a series of classes and things, and when I needed to wet my whistle, I would ask for questions. So can I take a quick questions break? Anybody got them? Also, how is the audio with with this whole situation tonight? Is it how is it? Open question. It really is just a slightly sour ale, which for those of us who don't like sour ales is quite nice. Audio is dandy. Oh, good. That's great. Thanks, Thomas. Audio is good, Chris. Thank you. Yeah. Well, neat. Well, it's like I say, it's a little bit awkward for me just to get used to, but as long as it's sounding okay, that's what counts. All right, so let's get in here. Maybe we can just turn this part into a hook. Let's see. Let's do this properly. Let's get rid of those. We'll do this inside of components. We'll call this our... Excuse me. We'll call this our hook. Need some servos and face tracking. Chris, if there's one thing that I'm learning from this week is I definitely don't have enough projects. So I think I'll get right on that. So here is our pin as a mesh. And let's see here. I'd like to construct a plane through two edges. I might need to take this mesh and turn it into a different kind of surface here. If I can remember, here we go. Surface. Let's see. Let's see here. Rigid joints, contact sets, modify, construct. Plane through two edges. Will you let me do this in mesh space? Maybe not. Let's see. Untrim, unsplit, split body. Yeah, it's not going to let me work with... I have to convert this to a different kind of mesh. And to be perfectly candid, I don't remember where that tool exists now. Let's see here. It used to be... Oh, maybe it's here now. Bodies. Mesh body. Create components from bodies? That's not quite what I want. Used to be a convert to... convert to object or something like that. Where did that exist? Press, pull, assemble. Motion link, no. Let's see here. What am I thinking of? Is it under tools? What's in tools? 3D print, make, utilities, inspect, select is what I get. Component color cycling toggle. Well, that's exciting. It used to be in what was called the patch workspace, but the patch workspace is like 3 versions gone. Let's see here. Mesh to B-rep. Yes, Thomas, that's what I'm thinking of. Where is mesh to B-rep now? Enable our mesh workspace preview in preferences preview to try a new mesh editing workspace. Oh, yes, you have to disable the timeline. That's right. This does ring a bell. Here, let us save this before we get too far. Do not capture design history. Yes. And now let's see here. Convert. Yes. Convert quad mesh to T-splines. B-rep to T-splines to B-rep. No, that's not quite it. Mesh to B-rep. Thomas, my hero. There we go. All right, so now let's re-enable our timeline. I guess I might be a little bit screwed. I guess I'll do the plate that will mount this in as a separate assembly, so we don't get screwed by having to disable the timeline again. Let's see. So now we'll go into pin experiments, capture design history. There we go. Yeah, there we go. So now hopefully I can do plane through 2 edges and cut this thing in half. Yes. Go back into our solids workspace, split body, that body with this tool, split. All right. So now, yeah, there we go. And now I've got half a pin to play with. I guess one thing we'll learn is if this is the appropriate amount of clearance here to fit snugly inside of our hole. But I think there's no real way to know without trying. So let's just make our hook. So we'll make a new sketch on this face. We'll make a rectangle here. That's going to sort of be the plate that sort of interfaces with the bottom of our Demilight. And then we shall, LX, find our midpoint here. How do I do this? I guess I will. You know what? I'm not even going to be that fancy about it. I'm just going to mirror this across our center line and call it a day. Mirror. There we go. Finish. I should probably think about printability here. So probably this hook only wants to be as wide as the actual pin itself, right? So we'll make this collinear to that. Oops. If it'll let me. Maybe coincident will be happier. Coincident to that? No, not happy about that at all. Maybe, here, let's try projecting both of our faces. And then let's try collinear again. Collinear. Oops, failed to solve. How strange. It's not quite happy playing nicely with this B rep here. But that'll be okay. I think we need to just sort of get within 0.1 millimeters for our slicer to be happy, and I'm just going to do it by hand. Because like I say, this is just an experiment for experiment's sake. So now let's see. How wide is this turning out to be currently? This is... almost exactly 10 millimeters, which is what our original hooks were, that's kind of handy. So now we'll extrude our various surfaces upward by our 16 millimeter height. Not that the hook is necessarily the perfect shape. In fact, there's good reasons to think that it's not. But just for the sake of consistent testing for now, it seems fine to replicate that same hook shape with all of our pin experiments. So let's see here. I need a point on this side, and we said this distance was what? That distance was rough. Turn the calipers on. They work better that way. 7.8 millimeters. All right, so 7.8. Oops. That is 7.8. No, not 7.8, Fusion? Not at all 7.8? It doesn't want me to change this dimension. There we go. Something seems off here. Something seems not. What's feeling strange? Maybe maybe not. 7.8 on the inner dimension. Yeah, that seems right. Okay. Well, that's fine. I guess the hook itself is thicker in cross section. Oops. And I was going to, much like our other one, we will have a slight overhang here at a 10-degree angle. And then we will extrude, join. Okay, so there is our pin hook, which is kind of interesting. Now, I wonder with this one, I'm actually going to take away that overhang, because I think without it, this is quite printable, and with that overhang, it's not going to be as much without supports. We'll just do one of those for now. So that's our potential hook. I hear printier noises behind me. I think our first print is almost done. Well, that timed out very well. Well, let's finish up what the hole would be for this print, and then we can print that one while we play with the first one. That seems good. My camera's like falling off. There we go. Let's see here. So let's work on the hole that would go along with this guy. We'll do it as a new assembly, since thanks to Thomas. Oh, what does Thomas say? Thomas says, really wish you didn't have to turn off design to convert like that, but at least it works and Fusion has gotten better. Yeah, it's true. Like, I remember back in the early days of Fusion, the STL import function was basically unusable. And now it seems like other than me not remembering how it works, it seems to work okay. Ooh. Cookie says, here's a good aside. Cookie says, I just realized you can use existing hardware to make a raised center pipe. Check Twitter for the pic. Ooh, I like this. All right, well, let me, on a yet another monitor here, I'm just going to whip up Twitter. And, ooh, check this out, y'all. Yeah, so this is Cookie's parrot pipe adapter, right? Something like that. If you print the parrot standard STL, you can use 2 grapples to get an internal pipe like Tyler Truss. Yeah, so if you were doing like a either a moving light like sucked up inside the truss here, or like the stick the par 64s inside the truss or what have you, like that's a really cool repurpose of that existing design. It looks like Cookie, and you tell me if I'm wrong, there's a wing nut in the back, so it actually is like through bolted and secure in this position. That's super cool. Yeah, if y'all haven't checked out, and like I said, the link is down in the description. Check out this this truss set that Cookie has put together. It's pretty neat, pretty nifty. So let us now play with our hole here. I want to insert from my computer. Oh, not SVGs though. I want to insert a mesh. Let's do the centerpiece. Hit OK. Only thought of it because you started mentioning raising the light inside. Yeah, so that is, I think, given the dimensions of the base that I'm working with, that might be a possibility. I mean, it's so close to the actual size that... I mean, one thought I had, right, was, like, just put a couple of rare earth magnets in the base of these and, like, magnet it to a plate on the inside of that truss, right? So not a super... Although now that I look at this is kind of an evocative placement, huh? Like, if there was some kind of connector where that sat as a part of the bottom of the light and this went up and, like, locked into place that way, like it had like a twist connector to it. So that, I don't know if that made any sense, but I'm imagining, we grab an unencumbered base here, right? If this had some kind of flange or protuberance on it so that it could just go up like into the truss itself and then into place and sort of friction fit there, that's kind of interesting. All right, more things to think about. Let's get our pinhole, as it were, sussed, and then we'll go from there. So I think this is a shape that I'm just gonna probably just, well, I was gonna say I wanted to recreate, although I think maybe the shape is more complicated. Like, it's not just a hole with, well, maybe it is, with filled sides here. Just thinking about what's gonna be the most expeditious way to take 2 of these holes and combine them with each other. But I think first things first, let's go into our surface workspace here, and yeah, I can't even split that right now. So yeah, so let's do our mesh to B-rep trick again, and we'll save this real quick. We will turn off the timeline. We will... Can I do it right from the right-click menu? No, of course not. Modify, mesh to B-rep, new body. Cookie says, yeah, they're expensive M4 wing nuts from China. Yeah, fair enough. All right, so let's do an offset plane. Let's see, how about -5 millimeters that way, and we'll do -5 millimeters the other way. Seems a little far, but we'll be a little generous there. And we will split this body using 1, 2 tools. Oh, something bleeped and blooped at me. Oh, but now it seems to be happy. I always get a little nervous when things bleep and bloop, but I think we're doing okay. All right, so body number 3 here is the one we're working with. Actually, this might be a useful way to like get inside this thing and figure out what its dimensions are. Because it would sure be nice to just replicate this shape. What I'm worried about is that like it's not purely a cylindrical profile with a diamond at the bottom. It's this. Like I think there is some contouring to the innards of this shape. Here, you know what? Let's take this back. Let's not just cut this hole out. Let us instead just split it in half and have a look at its guts. So we'll take that triangle and make a mid-plane, and we'll use that to split our body in half. Split along that plane. Oops. And, oh, no intersection between target and split tool. That doesn't seem right. Split body, this body, using this tool. Split. No intersection between target and split tool? I don't believe you. What? How can that be? Hello? Well, let's try one more time. Because sometimes doing things, three identical things the same way, sometimes has different results. No intersection between target and split. How strange. Let us try, just in case there's something weird going on with like it lying exactly on a vertex. Let's put an offset plane 0.01 millimeters off from our exact midplane and see if that will split. Split using this. Yes, it will. So I think what was happening there is like the midplane of those two faces we happen to be using was like exactly on like the intersection between two planar faces, and it was saying, well, I'm not intersecting this face, and I'm not intersecting this face, so I'm not actually intersecting the shape. That is a flaw, I would say, but here we are. All right, so let's make a sketch here and just have a look at the contour of this hole that someone else designed, because I'm gonna steal it. So let's take some. I guess the thing to do would be to like, let's see, let's project this layer and let's do the wick trick, and we'll copy and paste some sketch objects over into a new object. Can you copy? Here's the thing I don't know. Can you copy and paste sketch objects like lines and points between sketches? That would be awfully handy. I just don't know if you can. Let's find out. Let us select some sketch objects here. We'll copy them, finish sketch. We'll create a new component. We'll call it new plate. And here, we'll turn off the old one and the old sketch, and we'll start a new sketch on this plane. Can I paste? Ooh, it thinks I can. Yes, I can. So there is the profile of our hole. That's going to be great. Now, it's not in the most convenient orientation, but that's okay. We can work on that. I guess it doesn't actually necessarily need to even be in the perfect orientation for us to manipulate it here. So let's do this. We'll do a move copy, and we'll do a Z angle rotate. And probably the right thing to do here is, well, 2.5 is actually looking pretty good. It's like lock, dimension all of this out so that the relationships between these lines and points to each other is constant, and then just set, like, for example, this top line to a purely horizontal position. That would be the right way to do this. The quick and dirty way to do this was just to mess around with the dimensions until this top line looked roughly horizontal. And then we'll just sort of base everything off of that. So now we just have to turn this thing into a solid we can play with. So let's see here. Let us start by creating a box of sorts to surround this object, just so we have some negative space to fill. And so I'll make this rectangle collinear with this. Oops. Yeah, see, okay, so that's what I was worried about, is now it's getting all kinds of funky because these lines are not really locked in place with relation to each other. But I think we'll get by. All right, so now if I take this shape, for example, and revolve it, let's see, around this axis, and I may want to split this in half first, yeah. So, oh, my timeline is still disabled. Oof. All right, well, no time like the present. Let's re-enable that timeline. And we'll edit our sketch. Edit our sketch. Edit our sketch. Ugh. Killing me, Smalls. I should have re-enabled history as soon as I did the conversion to B-rep, but c'est la vie. So what I'm going to do is basically project everything from this. I guess I don't have to project everything. I can just project, say, a singular point, and then we'll come down like that and finish. Why? Oh, right, because... Can I not project all these objects at once? Be a real shame. It's interesting it won't let me, and maybe it was because I was before I captured history. Can I not edit a sketch that I created before I was capturing timeline history? That sucks. That is a real shame. But lesson learned. Let us just bring all the relevant parts of that sketch into our new sketch that does exist on the timeline. And we will continue our center axis up here so that we have something. So this is something that happens sometimes with revolves, right? Is I want to revolve really just one half of this shape. Let's say I'm missing one bottom line here. I don't want to revolve the whole profile 360 degrees because I would end up with the shape sort of doubled, as it were. Revolve. This is not a closed shape either. What's happening here? I'm missing some lines. Yes, here we go. Oof, I'm really paying the price for not re-enabling history when I should have. Do I have two separate zones now? It looks like I do sometimes. Yes, because I have both my sketches on. I'll turn that sketch off, and I should have... Oh, unless I have it just in this sketch. Oh, this is killing me. So what's happening here is if I could go back into this first sketch and draw just a single line just here, I'd be golden, right? But I can't. You can only, if memory serves, and someone correct me if I'm wrong, you can only take a create action on a set of sketch features that are in a singular sketch, right? So I can't say extrude this from this line from sketch 1 and this line from sketch 2. I actually need them to be part of the same sketch, and so now I'm sort of having to recreate sketch 1. Yeah, here's another unfilled hole in my sketch profile here. Let's see. Do. Just gonna go. This has now just become a Filling in Lines stream. Welcome to Sunday Night Filling in Lines with Jeff. And friends. And Truss. This is good. I feel we'll push through this, and then our reward will be getting to play with the thing that just 3D printed. That'll be fun. All right, so revolve this guy. Yeah, there we go. Revolve this profile around this axis. Oh, no, not that axis. Profile oh, how about around? My axes are not. Go terminal. Come on. All right, let's go back in. Go back in here. And we want this to be coplanar. Oh, I guess we could rotate around this axis, because this center line is something I drew, but this bottom line is the actual point, so we'll revolve around that. So revolve this around this axis. There we go. And I should have a hole in the middle, and I do. It's beautiful. Yes. Thomas says... Last night I was looking at data sheets. Tonight I'm soldering. Tomorrow night I'll be smelling burnt semiconductors. Yeah, that's the circle of life, I think. All right, so here's our hole, as it were. And so what I guess I'm proposing to do is, with tolerance, basically make this a cruciform hole so that... Where's my pin? Here we go. Let's take the dimensions of our pin here, which are 4.4 millimeters. Dimensions of this hole are 5 millimeters or so. So let's turn that into some things. We'll come back over to the computer, and let's take our center point right at the bottom of our hole there and give ourselves some construction lines to work off of. And then let's see here. Let's think this through. So these we will mirror across this center line. Yes, and we want the total width of this to be 5 millimeters. Yes. And then same thing here. We'll take that. We will... And the mirror tool for sure is not the only way to do this. You could do this with 2 rectangles and an equals constraint. Mirroring is just sort of the way I am used to thinking about it. And we want the dimension across here to be 5 millimeters. Here, I think we have found the flaw in my plan. Dang. Okay, so here's what's happening here, Rick. I was proposing that we would essentially have 2 holes that looked very much like this at right angles to each other. So you could only put it in this orientation or this orientation, which means your hook could be this way or this way or this way or this way, right? 1, 2, 3, 4. What it looks like, though, is that because of the dimensions of this hole, and really because this arc is, I guess, more than 90 degrees of arc it's turning out, which I guess I don't know that I believe, but maybe it's the rounding of these corners that's hiding that. If we were to sort of try and square off the corners so you could only put it in those 2 positions, you don't end up squaring it off at all. Like, so if we look, this here, if you follow my mouse, this here is the sort of north-south hole, and this here would be the east-west hole, and they actually overlap just slightly in this corner. They just, like, there's not actually any space in the corners here to fill in between them. Which is a bummer. That was gonna be such a clever idea. Beans. Well, all right. So here's what I think. I think we've spent lots of time on this construction here. Doing a thing and then undoing a thing. So here's what I'm gonna do. I think we're gonna print this block to play with, and print the hook that it goes with it. And while we're printing them, we'll play with the prints that we did earlier from that other idea, and then we can come back to this. So let us print some things. So we will save this. This will be, we'll call this pin plate. And we'll go back to our pin and hook design, which looks a little goofy, but I think this idea has some possibilities. And this will be our pin hook. And we will bring back into our slicer and import those two models. It looks like our pin plate didn't come in. Pin plate. Oh, it helps if I export the correct body, I suppose. There we go. Save as STL. This is our pin plate. All right, and we'll bring that into our slicer. Pin plate. All right, so let's rotate that. And this we said was going to print 180 degrees of rotation away from this. So we'll go all the way upside down, bring that over. And let's turn off supports because I don't want any spurious supports showing up, especially in the middle of that plate there. So this is going to be a 28-minute plate. That feels about right. Probably I should be printing this at a slightly higher quality, like at a lower layer height, but for the sake of an experiment, we'll call this pin. Let's call this pin hook is fine. Save. All right. So now I'm going to pop up. We'll get the print and the flash drive off of the plate there, and we'll start the next print. So as I understand, you can't hear me when I'm away, so good time to ask questions. Got this print here. I think who was it? Oh, Chris Gamble, who some of you might know. He does the Amp Hour podcast and runs a embedded electronics consulting company called Contextual Electronics. He's also a Chicagoan. Recently got himself a Prusa Mini as well, and with the way he phrased it, which I really quite liked. Oh, that's just a bunch of videos of my face. The way that he phrased it, which I really quite liked, was having a printer that you don't have to think about really does free you up to think about 3D design in a way, right? Like you sort of eliminate the tinkering with a printer as a hobby. I mean, we're never really done tinkering with printers. But it allows you to really just say, okay, well, if I can draft it, then I know I can make it in a way that is even more true with a really functional printer than just any printer. All right, BRB. Josh, it's good to see you here. Chris, I don't think the IPA percent matters particularly. I have used so I have a bottle of 91% that I use, but I've also used 70% and it works just fine. Really, the goal is to remove your hand's oils from the print surface, right? And so the difference between 70 and 90% IPA to clear off just some like basic skin grease, I don't think it makes a difference. I also usually will do it like just on the printer bed while it's heating up, and so both the oil and water, like the alcohol and water, evaporate very quickly. So like I say, I don't think it matters. I just happen to have this stuff, so I make use of it. Yeah, and Windex for the PTG is good. I have not ever experienced like the theory behind the Windex, I think, right, Chris, is that it actually acts as both an adhesive and a slight release for the PETG, right? So like if you use IPA, it can cause the PETG to bond too strongly to the PEI bed, at least is what I've heard. Excuse me. B. Pauling says the Mark... Oh, yeah, going back to the printers, my Mark III is the same. Provided the first layer goes down, I know I'm good. Yeah, it's like once your print is underway, you can just sort of leave it alone and it'll be fine. Speaking of things being fine, let's see how this idea worked out. So, we're going to have some clearance issues. So, like, that's a pretty tight fit, but I think I can... Maybe we'll clean it up a little. Oh, I've got some little crufties here left over from the supports. Maybe we'll take care of that real quick. Yeah, on our Prusa Mini that we have in my workshop at work, we only have the one spring steel sheet for now, and so we have one side that we use for PETG and one side that we use for PLA. And they're labeled, and it says, if you're switching between them, just make sure you really clean the new side quite well with the appropriate liquid. And so far, that's worked pretty much flawlessly. That cleaned up a little bit there. So this hook would go through. Ooh, it's a little snug. I got some more crufties from things, but this would be the idea, right? So this goes through the hole and then hooks into one of those sort of plate positions, and then that orients it so it would hang on the pipe like so, or you could rotate it 90 degrees to the next position. It would hang like so. I'm actually quite pleased with that mechanism in terms of like orientation at 90-degree intervals. Tolerancing needs a little bit of work, and I think actually we would probably want a larger and maybe a tighter fit on these registration notches here, right? Like, so and as foretold, the tolerances are a little bit loose, so it's a little bit wiggly. Because you could do 45 degree. Okay, yeah, that's true. You could probably fit in a notch just there for 45s and at least get 3 of them, right? And then, yeah, you'd have pretty much all of your options. You'd be missing the slot where where the slot is, basically, right? You'd have to. I also had the thought at one point, I don't know that you gain anything, but you could do essentially this same mechanism except with a sort of a T-shaped arm as opposed to a single-shaped arm, right? So if this was came up to an arm coming out of either side of this hook, and this was a sort of, rather than a keyhole shape, had a notch coming out this way as well, you would have just additional strength. And then it would register into the same set of orientations, right? So you could do this way, and you'd have an arm there, arm there, arm there, and then it would fall out here. So you'd have sort of 6 possible orientations in sort of 7. James says, when's this Truss going into rental houses? So, we're still working on the contract with PRG. We're going to see if we can get it on the Mamma Mia Spider-Man joint tour that's happening in 2022. So soon we'll get it on. We'll get it on the trucks as soon as we can. It's really nice. The Truss packed into, I think it's like 96 across road cases into a truck pack, so it's really easy. Chris says, could you rotate it and get the last 45? Maybe. Oh, here's an unfortunate thing. This hook can like slip down into the base there. 3D print a mini truck. It has occurred to me, Chris. I at one point road cases were on the table. Cookie's got 20 feet of this truss print. Yes, this is all Cookie's design, I should say. It got 20 feet to play with. That's very cool. This is like what I really should do is like, key up some segments of this and just like every time I don't have a print to go overnight, just run a bunch more truss because it's coming to that time. Let's see. Well, this is I think a good proof of concept, and I think there may be some benefits in like drawing on this like registration notch idea for other possible options. The other thing about this, right, like is it does require an additional small amount of clearance inside the body of the light itself, right? Because this plate is representing that plate on the bottom of the Demilight. And so we would need underneath the point where these hooks go in, we would need, let's see, if I register this in a slot, we would need this much clearance. Really, we would need, with this sitting not in a notch, we need that much clearance. The hook can go in, find its registration, and hook back in. Which we could always adjust the size of those PCB standoffs down there, but it's just something to think about. Oh yeah, get one of the belt printers for Infinite Truss. That would be very cool. Yeah, like the CR. Creality has one, and there's something else in the market now too. The Creality CR4. Somebody out there knows. Yeah, very, very, very cool devices. Not something I just got a new printer. I'm probably not going to get another new printer. Although Mary says I should get another one. I'm pretty sure is what she said. The CR30. Thank you, Thomas. Yeah, very, very nifty devices. Let's see. Should we check on how our other print is doing? Let's see here. Let's pull up our. Where's our Prusa Connect? Oh, it's gone away because we were looking at Twitter. But thankfully, I can just pull up 192.168.0.119, and we have. It takes a second to update. 18% estimated at 9:14 local time Chicago. Pretty good. So wildly, so one thing that I found, if those of you who have watched the video I did on the 3D printer status indicator, the Stacklight status indicator that I did a while ago, there's a very, very basic API built into the Prusa Mini, and I think you can actually access the raw data at the, let's see, API/JSON. I forget what the endpoint of it actually is, but it basically there's a little JSON endpoint that's saying print status, the name of the G-code file, the current Z height, and so on. It doesn't actually communicate the current status of the printer to this little local web page at all. Though the Marlin printing engine built into the Prusa Mini, of course, has a state machine, which is printing or preparing to print or bed hinting or idle or various error states or whatever. But this display isn't actually using any of those. All this is doing right here, if you look at the HTML that the Prusa Mini is directly serving, it says if the given G-code file name is an empty string, then I must be idle. If it's a non-empty string, then I must be printing. And those are the only two possible states, right? It has no addition. There's no way to show you that it's paused or waiting for a filament change or heating or anything of that. It's the most rudimentary possible thing, which makes using this page as a basis for anything else a little bit tricky. But Cookie says trying to get a hold of a UTM and get some span and load calculations in the next couple months. Currently, max span is 4 to 5 feet. Oh, that's cool. That's super cool. Cookie, you're out doing. I don't know if you can still see my dowel rods stapled to the window there by a country mile. That's super, super cool. Well, in the 20 minutes until our print finishes, maybe let's do a little bit of brainstorming on part 2 of this conundrum, which is not. So this is part 1, right? This is how the hook mechanism actually mounts into the body of the Demilight. And I think this has some possibilities. I'm hoping that pin model has some possibilities. Maybe a combination of the two. Maybe it's a locking hole with registration, or maybe the pin shape itself can be modified to give some sort of registration. I think that's got some possibilities. The other is, what should this hook itself be? Right, so this is like a really super basic design that I've been working with for a while. It's literally just a hook. It's a gravity hook. It hangs on a truss shape a pipe, what have you, like that. I do like that it's simple. Like, it's really easy to print. It's really easy to use and take them down. But as Chris mentioned earlier this evening, it's not particularly robust in terms of, like, you know, the light falling off of things. So my impulse is that doing like an actual threaded clamp at this scale is probably not a great idea, right? Like, I feel like that's going to be a little bit doomed to failure just for the sake of a side. I mean, it probably could be done, but I think then we're probably right back in the land of like tiny threaded parts, and probably some like metal threaded parts, which is what we were trying to avoid in the first place. If we were doing this all on a resin printer, that starts to look like a different process. But now, you know, again, we're making things more complicated when part of the goal of this was to move towards simplicity. So I think threads are out, in my estimation, at this scale. So what could this clamp, hook, it could be something with a snap fit. Like, it could be something, I really should just get a piece of paper. The original technology could be something like, if this is the cross section of our truss, right? If that's one of these horizontal members here, right now what we have is that, right? It's literally just a hook. Here, I can zoom in, right? It's a hook. What if instead it was something where, so part of my dream with this originally having that 10 degrees of sort of wraparound is to give it a slight snap fit onto a pipe or truss structure, which it would if it was exactly sized to the diameter of a truss member, right? So like even with this truss, which I designed it for, once you build in tolerances, right, you can see how that 10 degrees of overhang is giving us a little bit of a wraparound factor, but there's enough slop in here that this isn't actually going to clip onto the truss in any meaningful way. It's just going to, you know, sort of hug it a little bit. But I wonder if there's some other kind of snap fit structure that would do us better and have a little bit more flexibility in terms of tolerances. Because I certainly could tighten the tolerances up, right, and go with something like this. I wonder if adding, I'm just sketching here, right, we maintain a little bit of the overhang and add like a small nubbin, for lack of a better word, a little captive part in here. Figure out flex limits. Yeah, so part of this, right, is part of the goal of the project, nominally speaking, is that people can print these at home, and it pretty much works on a fair number of printers. Like, and actually, I'm really grateful now. I have a nice new printer. I have a kind of old crusty printer, right? And my dream is that it would work out of the box on both of them. So being super precious about tolerances on these is not necessarily the way I would choose to go. Although, you know, it probably is within the tolerances of either of my printers at this point. But if there is a design that takes a little bit of that guesswork out, I guess that would be preferred. Josh says a millennial with a printer. Yeah, but with a whole other axis. Millennial with a printer. Yeah, we have a real printer. We can print things on paper and everything. Work on the hot glue 3D print. Okay, now we're just getting silly. There's only so many printers we could have. What if, okay, just sketching. Here's our pipe again. What if it was something like vertical here, cross member, let's do a better sketch. Pipe, vertical, cross member across the top of the pipe, and then like a spring fit thing here that hugs the pipe that way. So it's sort of like you press the clamp down and it has to spring open a little bit and then clamp down on the pipe, right? And if it had enough spring to it, it would tolerate some variations in pipe size, so to speak. We might be able to get quite clever and think about, and I'm saying this out loud not knowing if it actually makes sense, is there some kind of like contouring to this inner wall here, or the shape of this flexible arm that is purpose designed to accommodate pipes or truss members of different size? You know, so that if it's this size, it's designed to sit at this point on the arm, and if it's this size, it's on this point on the arm. Like I say, I'm just kind of making that up. Kree did made a snap fit piece that worked well. Kree, is it one of your Truss designs that you've published that has a snap fit? I've done a couple of snap fit things, but not a ton. So I guess I'm a little bit gun shy about it. Let's see. Think of those little plastic clips on new clothes / folded shirts. Ooh, yeah, like the little Be Pauling, you're thinking like the little, like, almost like a bobby pin kind of a shape, if memory serves. Or like if it had various sort of tapered nubbin points. Yeah, So it would sort of ratchet in there a little bit, which I find appealing. And if the shape was something like, you know, up, and not thinking about the thickness of the object itself, but it had a large, and then let's see, we'd want to go the other way, I guess. If it was, you know, small, slightly bigger, slightly bigger, then you sort of just notch it in until you get to the point where your pipe stops. So the big pipe stops here, and your slightly smaller pipe stops there, and your slightly smaller pipe stops there. Or cotter pins, sure. Yeah, that's a good analogy for what these are, right? We're sort of reinventing cotter pins. That's kind of interesting. It does aesthetically, right? Like, it's a little bit. Although this is kind of interesting, right? If letting alone the, like, it fits multiple sizes of pipe for a second, this is kind of interesting just as a form factor for fitting this size of pipe, right? Rather than trying to do my first idea, which is to get all the springiness into essentially this little tiny moment arm, having a shape that gives us some extension above that point, and it's designed to clamp sort of there. And now all of this can flex. That's kind of interesting. I think that stands a chance of working pretty well. And, you know, we can forgive a little bit of additional height in our clamps in our model moving light universe, as it were, I think. Yeah, Be Pauling, that's that's an interesting idea. This is the kind of thing that feels like it's going to need a fair amount of iteration to get right, but I like it, and it's relatively easy to print. Although it might be a little bit tricky. Well, maybe not tricky, but we'd have to play with what the relationship of it to if this ends up interacting with the, you know, the pin design here. Part of this pin design really requires it to. That's a good fit. To print flat on the bed like this. And so, and this shape, we'd really want these to exist so they print like this, where this is the flat side of our pin, this is the flat side of our profile, I guess, if this is our profile. So it all is basically a flat shape printed on the bed, but that does mean that this point is printing in space, although it's only like a 45-degree angle, so I think that would be okay. Let's see, if this wants to print, this would basically be our printed shape here, right? Sort of a hooky thing with a pinny thing at the bottom that would lock its orientation. It's kind of interesting. I think it's got merit. Let's see. Let's check on our print status here, and we'll see how we're doing. Because really this pin idea is dead in the water. Then we'll have to investigate something slightly different. But I like that. Chris, have you seen Cable Monkey? This rings a bell. Is this like the Truss, like dressing clippy thingy? Cable Monkey. Oh, I have seen this. Yeah, I mean, for me personally, I think it's a silly thing to have on a truss for most applications. But it's an interesting design, right? And this is essentially this shape here is what we're thinking of, right? It's like a circle. Go back. A circle that fits the size of the circular thing and a sort of a spring clip area that holds it in place, right? And then it's just a matter of figuring out what the dimensioning and what your materials are so that it actually does that springiness. Yeah, that's kind of neat. Well, let's see. We've got 10 minutes until the pin finishes. Let's make a real quick clip that we can play with, and we'll print it right after that. So let's get back to Fusion. We'll do another part. And I'm not even going to bother integrating the pin with it this time. Let's just do some clip experiments. I'm going to grab my calipers here and take a quick measure in the field measurement of what the D3D Truss printed out as 6 millimeters across there. So let's say that this is a 6 millimeter piece of pipe. Let's say, a tolerancing here is going to be, this is going to be the thing that would need iteration, right? It's like, what is the actual tolerances in all this? But just for the sake of this evening, let's say that it's 0.2 millimeters all the way around. Yeah, Cookie, if you have the actual as design dimensions, I'm getting just over 6 millimeters as printed on the members of the truss here. Let's see, and then let us. Here, we'll just strike a line, we'll make it vertical, and we'll make it tangent to this circle. We'll make this... Bring this all the way down, and let's offset this by... Let's make this a 3 millimeter clip. Is that going to be too stiff? Another important question. How stiff is too stiff? But looking at it by eye, that's going to be quite a stiff thing. So let's make this like 1.6 minus 1.6. So it goes the other way. There we go. And we will make this coincident to our circle so it lines up right there. We'll make a new circle that is the width of the thing. Chord is 6 millimeters. 37-degree extra hook, says Cookie on the snap fit. And chord is 6 millimeters. Well, that's a good sign. So let's see here. What I think we're gonna do is we'll bring a line across, and we'll just use we'll eyeball a fit point spline to be the other part of our hook. Let's give this a dimension just so it has something to work off of. Let's make that 1 inch. It's a little silly big. Let's make that 20 millimeters. And let's make this, we'll give this an offset by, can I not reference my offset dimension? That's unfortunate. How about 1.6? There we go. Yes, and of course it's doing a linear offset, but that'll be fine for our purposes. And we'll just cap this off with a circle here. This is not my best drafting ever, not my most robust drafting for sure, but again, just for the sake of experimentation and getting it out quickly, and stealing more excellent ideas from everyone who's here tonight, which I very much appreciate. This will do well enough. All right, so here's roughly the idea, right? We'll extrude this just so we're clear on what we're working with. We have something like, so this innermost circle is the dimension of the pipe itself. Then there's a little bit of tolerance for the 3D printing process. And then, so I think I need to put my my spline here in a slightly different place, because I don't want to go inside of the tolerance of the circle. I want to go outside of it. So let's move that just there. And let's adjust our offset down here to be just slightly smaller. All right, finish sketch. And let's double check our extrudes so that we're making a clip and not an awful thing. Yes, all right. So I need a little divider here to make this into 2 separate shapes. And we'll clean up our extrude sections and take that out. So here is our hooky thing. Something like this that just like clips over the pipe in a way. Yeah, something like that. I think that's the gist of it. I wonder. Let's see here. I'm gonna just see to my pants. And like so, this we're just eyeballing this, right? But I think we're gonna bring this in a little more and bring this out. So it's got a little bit more clampative force, maybe. I don't know if that's actually going to work, but that's the idea. All right, so we will save this as clip clamp. We got 4 minutes until our other print finishes, so I feel pretty good about this. We will export this as an STL. We'll call this clip clamp. We will bring that into our slicer, import, clip clamp. We'll spin it into place. There we go. Slice. This is a 7-minute print. Oh, I was about to say we were probably not going to get to this one tonight, but I think I might have another 7 minutes in me after that print finishes. In fact, why don't we do another revision of this? So let's make a new sketch on our origin layer here. We'll project this whole body, and we will copy paste. Oop, the whole body, please. Copy paste. Oops. It's not letting me copy projected lines. It's this same issue again. All I want is to project. Got 3 minutes till the print finishes. If I can't get it by then, we'll wave off on my futile attempts to make a revision. You know what I really should do is like parameterize that first sketch in some kind of appropriate way, and then record the parameters, and then change them. So here, let us see what this angle is. 50. Here, let's make it a nice even 60 degrees, and that'll be good. So let's. Before we go on, we'll make a 60-degree body. We'll save that. Save that out to an STL. Yes, and we'll bring it back and reload from disk in the slicer. Okay, and now we have a 60-degree option. Let's do a let's do a 50-degree option. Let's do it really tight, and then we'll have to sort of manually adjust that line, of course. Yeah, so not a particularly well parameterized solution, but again, for the sake of experimentation. Did I make these coincident by accident? I did. Which I don't want. So I'm going to get rid of that coincident constraint there. So we can bring this back over. Yes, there we go. Finish sketch. All right, so that's an even tighter squeeze, as it were. And we'll save this as clip clamp 50. Bring that into our slicer as well. I haven't asked, can you hear the 3D printer behind me at all? I guess I was a little more worried about it with the lav that I usually use, just because Chris can hear the printer. Fair enough. I guess also my headphones are fairly noise canceling, but it might be Chris's Bruce in the other room. Chris. That need a better control for that setup there. All right, we are almost done with the pin clamps. Let's see here. What's our status on those? Ooh, I think I hear it finishing. It really is quite quiet, except when it does big moves, like it just finishes a print. Thomas can't hear it. Well, that's a good sign. All right, so all right, let's see here. Plug in the old flash drive. Bring up the as printed. Take the clip clamps, put them in the flash drive. I know you can't see this. It's on my other monitor. It'll be just a moment. Eject. All right, take flash drive. The Prusa Slicer and the Mini think that that's going to take 8 minutes and 42 seconds to print, which I feel pretty good about. So, and probably a good chunk of that is the bed leveling. So good. So we have 9 minutes to play with our pin solution here before that one's done. This will be good. We'll play with this a little bit. We'll see what we learn. We'll play with that briefly. We'll see what we learn, and then we'll call it a night. I think that feels good. So here's the test. Does this work? Ooh, it's real tight. Something's gone wrong. I wonder... Ooh, you know what we should try? Let's take one of these pins. Yeah, uh-huh. So that clicked in fine, and it spins and everything. But you know what I didn't account for? Part of the flexibility of this pin is due to the fact that it has, yeah, exactly, Chris, not enough flex. This has the entire length of this to flex. By chopping this pin in half, we've really limited the amount of flex that it has. So really, if we wanted to do this, we would make, instead of what I should have done, what I will do next, is instead of cutting this pin in half and welding a hook on top of it, so to speak, I should have, taken the entirety of the pin, and my structure should have started here instead of this cone. Well, we have 8 minutes. Should we see if we can get that change in? Let's come back to our pin experiments. Let's see here. Let's just roll back here to point in the timeline where we cut this in half. Oh, everything's gone yellow. For some reason, my Flux, my screen correction app, just kicked in all of a sudden there. Even though I have it set to disable until dawn. Well, that's frustrating. So you know what I'm going to do is I'm going to take my cutting plane here, and instead of putting it between those two lines, I'm just going to move it up and put it between these two lines up here. Yeah. And then hopefully when we cut... Yeah, that looks better. Now this sketch plane, let's see if that's in the right place. Let's turn our sketch back on. That's now up here, although this has shifted way off to the side. That's no good. So let's go in and edit that sketch real quick. We'll just drag this across. Casual do, as we did before. Good. And our first extrusion is where? Is the wrong way. So let's say this is... I can go back and figure out what the actual appropriate dimensions here are at some other point. We'll say -8, turn our body back on, and our hook. So our hook looks something more like that. Now, does this part of the hook really need to be tapered and chamfered like this? I don't know. Ooh, you know what I actually do want? I don't want... When you put these pins in the existing part... Oh no, that's actually okay. I was gonna say there was a little bit of like in and out wiggle, but that's actually not true. That pin and that pointy end really does sit right down in the mount there, so that's not really an issue. I was thinking about, do we want to put like a little additional lip just here, but I don't think that's necessary. All right. Well, rather than trying to integrate the squeezy clip into this, given that we only have 6 minutes left until that's done, well, maybe we could put the squeezy clip in. But I think I think we would just print this. And and we may not even get to that tonight. To be totally honest. But that would be all right. Well, yeah. Well, in the 5 minutes now before that finishes printing, I'm trying to think if there's any other Demilight updates that are pending, but I don't think so. Oh, so those of you who were with us last week remember the issues we were having with the 0.95 board. I have successfully programmed a couple more of these in the meantime, so I think the only issue was that issue with the TX and RX ports being flipped, as we saw last time. The TX and RX were backwards, so I'll fix those on the 0.96 rev, and that will be done. I have not put the order in for the 0.96 boards yet, so they probably will not be here by next weekend. Ditto the Pocket RDM controller. I have just been so... I don't know if I mentioned this earlier, but the transition back to working... being on site at my job full time really threw me for a loop. Both the different sleep schedule and the work, and also, as y'all know, like the effort of being out in the world right now is just a lot. So it really knocked me out for basically all the evenings this week. So I've only really been working on Demilight stuff this weekend. So a little bit of lack of progress there, but that's okay. So, but the good signs for 0.95, other than this one simple error where I screwed up the TXRX, but that'll be an easy fix, and 0.96 should be in a pretty good state. Let's see, what else? Playing a little bit, I think I mentioned, with like different, just using up different filament colors to print out various Demilight parts. So like this I think is maybe my favorite. It's got like, ended up with basically copper down the side and a white body and a blue stripe. It's kind of got like a Speed Racer-y vibe, I think, which I like a lot. And I really like how because of print orientation, you end up with the different colors on different sort of orientations on the light, right? So this printed with a copper layer down, which means that the yoke has it on the back, but the light has it on both sides, and the lid has it on the bottom. I don't know, it just ends up in a kind of a cool way. Also, I know I'm sure it doesn't come across on camera, but this first layer is just silky smooth. It's just so beautiful. I'm just so pleased. But anyway, what else is going on in Demilight land? Not a ton. I should have my actual ISP programming header, my PogoPin ISP programming header here soon to play with, because this abomination is not going to hold out forever. These are actually, so these PogoPins are not even, let me see this. Yeah, so I had bought these for an old experiment. These aren't even the full size. So they make pogo pins in a variety of sizes. These ones are meant to be on a 50 mil spacing. They're really tiny. Okay, I think you can tell just from like the scale of my hands, like they're super duper small. They go in a real tiny hole. They go on like, so if I'm by 50 mil spacing, right? These standard, breadboard holes and perforated holes are on 100 mil spacing. These ones are meant to go on half that spacing, and that was why I bought them, because I really wanted to squeeze them into small space. And then I found that was just not bearable. But the only pogo pins that I had on hand when I was prototyping that thing. So, Chris says RDM updates. Nothing huge. I did a little fiddling with the JDMX RDM library that I'm working on. I'm at the point where the actual, let's see, I've got a minute. I can boot up VS Code. Most of this, I tweeted about this at some point, which, by the way, if you're interested in this kind of stuff, I'm on Twitter at JeffersGlass. That's not on screen. Oh, it is on screen. There you go, at JeffersGlass. Come follow me. Or come, that's like, honestly, if you have questions about this stuff or you're working on stuff and you just want to say hi, that is the most expeditious place to reach me. Some folks have found me on, like, through Facebook, which is totally fine, or through the email address on my website, jeff.glass. But if you're like, hey, I just want to, like, shout out, say hi, or I have this question about a thing, Twitter, either public or DM, is the easiest way. But whatever floats your boat. So the RDM control part of the library is the easy part is getting it to send the correctly formatted RDM messages, right? The RDM message format is ultimately not all that complicated, and I have the luxury of the Conceptonetics library that I forked to do this had already taken care of the checksum code. And I verified that, and that works quite well, so that was an easy thing. So, like, I can send RDM commands out, and the tricky part, of course, is implementing the logic behind sending those messages, right? So things like how do we? So if we send a message out into the world, like set address, how do we validate that this actually happened, and what should we do, right? So at the moment, and to do this all in a very memory-constrained environment. So let's see here. What is the best way to explain this? So when the RDM sender sends out a frame of data, I don't know where this code is. It's been a few days since I was working on this. But it basically will save a copy of the most recent message that it sent, if it was not a broadcast message or if it was not a broadcast message, unless it's a device discovery message. And when it receives a response back, the controller validates that it is an appropriate response to the message it most recently sent, and then passes the data from that response onto the user's code. So here's a little tiny chunk of that, right? And so part of this is like trying to validate trying to figure out the most appropriate program workflow for how to handle the fact that up until this point, the RDM library has been entirely interrupt-based, right? You basically store some data in a buffer, and you use, for example, the ATmega32/8's built-in serial interrupts to push out 1 byte at a time, and every time it's pushed out 1 byte of data, it knows to go and be like, hey, I have an interrupt here, please give me more data. You give it another byte of data from your buffer, and it just cycles through that buffer for you essentially in the background. What breaks that programming pattern is the fact that as a controller, if you were to say send a set address message or get status or really any message, you're supposed to wait up to a certain amount of time to wait for a response. And waiting in that way, waiting for either a timeout or a response on your DMX port is not something that's fully captured just by an interrupt. You need some kind of structure. It's a little bit hidden there. A little like this. That is either going to hold us in a loop, just waiting for a certain amount of time, or we're going to need some kind of, basically need to take control of one of the built-in timers to throw us an interrupt after a certain amount of time. And so, you're sort of damned if you do, damned if you don't, right? Do I want to make this library reliant on one of the timers for configuration, or do I want to have it seize control from user space for, 3 milliseconds every time it sends a message? And so far, the easiest one to prototype is just to say, hey, once you sent a message, wait 3 milliseconds and see if you get a response, and don't let the user do anything else. Re-enable interrupts for that time so timing can continue and servos can continue and stuff. But, don't cede control back to the user code for 3 milliseconds. And that feels like a bit of a sin to me, but I haven't come up with a better way around it yet. Anyway, you asked, Chris. I gave you the answer. Thomas says, I don't really have an update to share. Oh, yeah, Thomas is also building slightly larger but still small 3D printed moving lights. Larger, more featureful, more powerful for sure. Yes, yeah, they had that was the magic smoke that Thomas had most recently was from a voltage regulator. Still having fun driving steppers at high voltages. So much torque. Oh, nice. Yeah. High torque is not really a thing that I get to have fun. I moved the mic. Yeah, it's back now. Yeah, I for a moment I was like, oh, I'll just keep talking. It'll be fine. It'll be fine. It's not fine. I think our print is done anyway. So let me grab it and we'll do our third and final hook test of the evening. BRB. All right, so there are our two bobby pin hooks, let's call them. So we have our hook and notch. What do we call this? Arm and notch hook. We have our pin hook, and we have our bobby pin hook. That's gonna be a little confusing. Yeah, Lava's on the fritz, or maybe it's the phantom power adapter in the that I have on the audio interface. Or maybe it's just dead batteries. To be honest, I didn't have a spare battery for the Lava. It might just be that. It shouldn't need battery when it's in operation, so it claims, but it's a different mic for sure. To be honest, in my testing earlier, I think it sounds better than the Lav. It's just inconvenient. But I don't know how it sounds out there, but in my little local testing. So we have two. Wow, there's really almost no difference between those. There's no sort of meaningful difference in those profiles. But if one works significantly better, we'll know something. So let's see here. Let's see. Something like... Ooh, hey. That's awesome. That worked quite well. That one worked a little less well. It's a little bit more affirmative. I would say it's a little bit too tight. Yeah. Josh approves. Josh, are you approving of the mic or the 3D printing? I'll take your feedback on either, but if it's the mic, I'm very excited. This is the Samsung Q2U that I think you have recommended before. Yeah. I like these prints too, Chris. I think that's got some possibility to it. It will be an interesting thing to experiment with, because one thing I would want to do just for durability is thicken these up a little bit. I think we made them 1.5 or 1.6 millimeters, something like that. If they could be closer to 3 millimeters, I'd feel a little bit more robust about them. But we'll have to see how much that affects the flexibility of the arm there, right? And do the clearances change? But that's just iteration, right? I have to believe there is some amount of thickness and pinchiness that that will work for us at a slightly high. There's a certain amount of pinchiness that at a higher thickness we will be fine. Josh, I'm happy to have you here too. It's always good to see you. Yeah, I think this has some possibility. So I think where we've landed tonight, obviously this is getting modified along the lines of what we were looking at a moment ago, right? We need more flexibility in this pin, but I think the pin idea is essentially sound. I think, oops, there we are. I think the next draft of these is a pin mechanism. So here's the problem with the pin. Takes a lot of space. Takes a lot of vertical space. I wonder if there's a word. So what is the spacing here? On this, going from this point to some point here in the currently, the fully ripped off pin design, that is 20 millimeters, almost 22 millimeters. So where's our demo pin here? As usual, at the end of these streams, I've made a mess of the workbench, right? So basically, if that was going to be the base of our hook, everything on this hook up until that last point is inside the body of our light. And what I was just having a brainwave about is there any way... Grab an unencumbered body here. There we go. We'll do this fun two-tone one. To have the hooks shoot up through the corners or somewhere where we might have clearance. Because I don't think we have clearance to Oh, no, that's not true. It's only half of the pin. Highest point on the opening of the clip, right at the center of the pipe on the truss. Highest point. Oh, I see, Chris. I think also, so I think I misspoke a moment ago. So rather than in profile, the pin being here, it's actually here, right? Because only this amount of the pin needs to actually be clipped into a physical body. So it's really only 11 millimeters. And I wonder if I have a completed board. This is what version of board? So I have a 0.94 board here. We had raised the lid on the upper lid on this case at some point to accommodate these voltage regulators, and honestly some cable routing in there. I think it could, well, I'm trying to fight the urge to just make this case taller and taller. I guess we could go, like, the pins could sit outside of the footprint of this base a little bit. Like, we could have this exist in profile, or, in plan, something like that. And you stick a pin sort of in the outside and in the other outside. I wonder if we could do that in such a way that it would exactly match the span from cord to cord of this truss. Cookie Idol, are you still with us this evening? Can you get me a cord to cord distance on this truss? Chris has crazy idea. Can you flip the board over and use the space of the voltage things and the pins to be in space? Ooh, maybe, Chris. Part of the challenge is in the assembled lights, that airspace is also taken up by all of the excess wire from the hobby servos. You can see we sort of cram them in there. So if we were to do custom servos with shorter wiring, maybe. 44 millimeters center to center. Yeah, So just eyeballing it. Here, let me get the silver truss, because that'll be a little easier to see. Just eyeballing the existing Demilight form factor and these truss widths, I fully believe that there's a world where that hole exists. I mean, probably it's like exactly more or less, really could be the motto of these streams, right? Look at how that lines up. Zoom me in there. Right, those pins basically want to be centered on the existing walls. Yeah, so it would have a small bump out. It would have a small bump in, which we could tolerate, right? We have some internal clearances. I think that's very appealing. And then it would be sized to fit a 44 millimeter box truss, which is neat. Because I don't know if I said it, I like these trusses a lot. Yeah, I think that's got some possibilities. All right, 0.96. Pins, clips. So, things we learned tonight. Let's wrap it up. Things we're planning. A pin methodology to secure the hook to the light. Now thinking, I said I was going to wrap it up, and I have a bonus thought. Got to think about, like, how these orient. I feel like it's this way. So you hang across the truss. I guess also I'm literally just stealing this design for now. Maybe I'll iterate on it and find a version where you can do that, like, cruciform. It goes one way or 90 degrees in the hole. Maybe I'll work on that some. So let's wrap it up. Things we learned tonight. We can use these pressure pins that'll work quite well to do things like have a pin fit in a rotating notch in our moving lights. We tried these orientation notches, and I'm glad we did it. I've purged this idea from my brain. I think this maybe has some merit for a future idea, but it's not quite right for this one. And our chicken dinner of the night was these spring clips, which really do have a nice affirmative feel to them, and I think will work quite well. And I'll be playing with the thickness of these clips relative to their springiness, relative to how much pinchiness, being a technical term, there is here, and figuring out what the right dimension is there. And then to integrate that into the Demilight body, I'm going to think about putting a small bump out here so that these these pin hooks with their pinchy clips can sit at 44mm centers, and we'll use the D3D truss design as our truss model going forward. That feels pretty good. I think then, too, it's also relatively easy to be like, okay, if you want to use a different truss, what you need is a 44mm spacing that, you make your adapter hook onto. Thomas says, what if you used holes in the PCB as what the hook's clipped onto? Ooh, I don't hate that. We'd probably need to go... So there's not a ton of real estate inside the footprint of the PCB itself right now. We could make something like this the footprint of the PCB as opposed to coming out of the 3D print. But I think, yeah, it's a super neat idea. If we were going to get really fancy about it, it would be like there'd be 2 mounting holes in the PCB that the clips would clip into, and that would also secure the PCB in place. Although then you would have to have the hooks in place for the PCB to be secure, and I think we want those 2 things to be separate, right? Because often these are going to just want to sit on a desk or on your light board or what have you. Yeah, it's a neat idea. Thomas, tell me more about the image that's in your brain, because I'm curious. Just thinking about how that would, and certainly we can do a custom PCB shape, right? That costs no extra to do an external bump out. I just don't know, to be honest. Having messed around with this PCB in recent days, I don't know that I have room without some other significant modification, which maybe is in the cards, to find room on this PCB for more stuff without losing some things that I do want to keep, like I2C control lines are now on this version, and some additional I/O and our programming ports were fairly stuffed. One thing I do want to try and squeeze in is a connector for the LED, some kind of like little SM. God, what's the word? Like a little Molex style connector. Because someday, if these were to go out as kits, I think having a piece, can include an LED star with wires and have it connectorized is better than having people solder it at a fairly late stage in assembly, to be perfectly honest. But that's just me. This was a very productive night. Honestly, like, for a thing that I was like, well, we'll take a stab at this and we'll see where it goes. I'm very pleased with where we've ended up. And thank you, everyone, for being here. As I said, like, especially on these nights that's like, I don't know what to do about hooks and clips and clamps. Having people here and lending ideas is super, super helpful. So thank you. Thank you for all of the for catching my mistakes as they go, for suggesting different clip designs. The bobby pin clip I would not have thought of on my own, but Chris and B. Pauling and others were found that one out. Like, I'm so appreciative of y'all being here on these Sunday nights. Yeah, Chris, I'll send you a cut of all of my profits that I make from this YouTube video, let's say. Not of the Demilight. That's how I'm making my millions of fractions of pennies, let's say. Let's see. Thomas says something like pin from the cube, but smaller, which snaps into the PCB instead of the case. One of the reasons I wanted to go bigger. Yeah, a lot of the challenges in this are just coming from the fact that I insist on these things being quite small. But that's part of the fun that I'm having. I'm excited for the fun that you're having, and having the more opportunities and more space to do these things. It's very cool. Let's call it there for the night, y'all. Thank you all for being here on this Sunday night as we nerd out about tiny moving lights. It's lovely to see so many familiar and new faces as always. I hope you're doing well. I hope you're staying safe and wearing masks and washing your hands and all that good stuff that we know how to do so well by now. I hope you're hydrating and trying to get some sleep where you can. We'll be back next Sunday night with more nerdy things. Probably more Demilight-y stuff. Could be more Raspberry Pi-y stuff. This Raspberry Pi project may grow into something more intensive, and that might be a fun thing to play with. Or not. We'll see where we're at. Yeah, the team brainstorming, Chris, is like one of the most joyous parts of this, especially like up to and including the parts where people are like, Jeff, no, bad idea. No, you're doing it wrong, Jeff. It's like, that's awesome. That's super helpful. Yeah, it feels great. So thank you, team Demilight, for being other great brains out there in the universe. It is super helpful. Yeah, be good to yourselves this week. Get lots of sleep. Light to the end of the tunnel, all that good stuff. You know me. If you like this stuff and you're not already liked and subscribed, you know how to do that on the YouTubes. Like I say, find me through the website, jeff.glass/Demilight. There's an email address there. You can find me on Twitter, @JeffersGlass. You can put a comment on this YouTube video. You can... my Zanga has been shut down, so don't try to contact me there. Live Journal is long gone. If you find me on MySpace, then you have slipped into the past, and I'm worried about you. But I do know Morse code, so if you hop on to the HF bands on any Thursday evening, then I might see you there. Yeah. Now we get to find out if, at long last, having successfully avoided pressing the good night button all night, does it work? Let's find out. Have a great week, everybody. Oh, yeah. It worked.